Hi, in the previous video, I have talked about basics of graph, how to make adjacency list of directed and undirected graph. In this video, I will discuss about depth first DFS. This is one of the traversal in graph like tree or like in order, post order and pre-order in trees. Depth first DFS is one of the traversal in graph. Traversal means that means you follow DFS, then you will visited or you will visit all nodes of the graph. Okay, that means if you finally do DFS, then finally all the nodes of this graph will be visited only once. Okay, not repeated. That means you cannot, if you follow one path to visit this or follow one path in DFS, then you cannot revisit single nodes more than one. Okay, you can visit only one. Let's first some one simple example what is actually DFS and what is not DFS. That means BFS we can say, but actually what is DFS and what is not DFS. Okay, if one example like 1, 2, 3 and 4. Okay, if you try to traverse from 1, okay, starting is 1, where starting is 1, you can travel in many ways. If you try to 1, then one is you can start 1 and go towards 2. Okay, that if you first start from 1, then 1 will be added in list. Okay, this is list. If go towards 2, then 2 will be added in list. Okay, 2. Here let's one more 5. If you are at 2, then you continue towards 3. You can continue towards 3, and also if you are at 2, then you come back to 1 and try to visit 4. Okay, that means one combination is 1 2, and from 2 1 is try to go towards 3. That means 1 2 3. And another, if someone is at 1 and 2 and from 2 go towards 1, and from 1 he will go towards 4. That means 1 2 4. But actually this is not DFS. DFS matlab DFS, that means if in depth there will be at least one node, then try to cover all nodes in depth, and then after return and to cover another nodes in another direction. That means in depth if 1 2, then if in depth another 3, then go towards 3 first and add a list. If there is any in depth node is remaining, then go towards 5. That means 5 will be added. Okay, and if 5 will be added in, and then after there will be no any or no remaining nodes, so you can return towards 1. Okay, and from 1 here 1 neighbor 2 is covered, so from 1 try to cover another neighbor. This is 4, so you go towards 4 and tick this 4, and from if you go towards 4 there is no neighbor of 4 that is unvisited. Also neighbor of 1 is 4. That means another neighbor of 4 is 1, but this is visited, so you cannot reveal it. But except 1 there is no neighbor of 4, so 4 is simply return call, and 1 towards 1, and 1 already have done all neighbors. So this is the actually DFS answer. Okay, this is actually DFS traversal answer. This is not 1 to 4. That means if you go towards 1 from 1 to 2, and from that means to left 3 and 5 and to go towards 4. This is not DFS. Okay, so I try that you first understand what is DFS. Okay, I think there will be some idea about DFS. And okay, if you actually follow DFS in this graph or DFS traversal in this graph to visit nodes, there will be many combination. If actually you follow right path in DFS, then there will be multiple combination and all these combinations are correct. Okay, if you follow 1 to 2, if you go from 1 towards 2, then first one is visited, then 2 is visited. If you go towards 2 to 5, then 5 will be visited. This is one path. But towards 6, this 6 will be visited. And you can also go towards 2, but 2 is already visited, so you can go towards 4. So 4 is visited, and finally you can go towards 3, and this 3 is visited. So all 6, 1, 2, 3, 4, 5, 6 are covered. So this is one of the DFS traversal. You can also follow another path. If you can start from 1 and go towards like this first one, another is 3. If you continue this path, then another will be 4, and if 4 you can go towards 2, so this is 2 will be added, and finally from 2 you can continue towards 5. Okay, so this is 5, and from 5 you can go towards 6, so this is 6, and all 1, 2, 3, 4, 5, 6 are covered. So this is also right, and this is also right in DFS. So there will be multiple answer and all answer are correct in DFS. Okay, now let's start actually how DFS algorithm run and how you can write DFS in practice or in problem. Okay, if you if you if you can't revisit any nodes again and again, then there will be one monitor that he will monitor all nodes, and if there is any nodes that is already visited, so it will stop that you can't revisit this node. So for monitor purpose you can make one visited area. Okay, of visited area of what size? Number of nodes. Okay, 1, 2, 3, 4, 5, 6. If you make one visited area, okay, one array is 0 based indexing. Okay, but here I have start one based indexing, so let's one based indexing array 1, 2, 3, so 3, 4, 5, this is 6. Okay, this is 6. Okay, initially all are blank, or you can say 0, 0, 0. Okay, you can take any as your wish. Let's start from 1. If you start from 1, then first pick 1 and visit. That means make 1 as 1, means from 0 you made 1 index as 1. Okay, from 0 you make 1, that means 1, so that 1 is already visited. Okay, and from 1, let's sustain. If you are at any node, then you try to go towards all nodes. Okay, let first from 1 1 will try to go towards 2. That means 1 will try to go towards 2. This is, let's try to change the color so understanding is clear. Okay, this, okay. If you go towards 1 to 2, that means you follow this path, then here 2 is, and also that means here 2 is unvisited. So if 2 is unvisited, you will tick, you will tick, you will tick and make value of 2 is also 1. That means here make 1. That means 2, here 1 indicates that this 2 node is already visited. If you are at 2, you will try all neighbor of 2. If you are at 2, then you will try towards, go towards 1, because 1 is also neighbor, but you cannot go towards 1 because 1 is already visited. How you can check? How can you check? If the here 1 value of 1 is 1, here 1 value is 1, so 1 indicates that 1 is already visited, so you cannot go towards 1. Okay, so you simply return. If you are at 2 and you already checked one neighbor of 1, then another 3 neighbor 5, 6 and 4 are unattempted, so 2 will try for 5. Okay, 2 will try for 5 and go towards 5. Okay, try for 5 and go towards 5. Okay, and say that 5 is unvisited. Okay, so tick this 5 and make 5 value as 1. Okay, now 5 will try for all its neighbor, then why 5 will may try for 2, and but here 2 is already visited because 2 value is 1. Visited area, that means this is visited area, value is already 1, so 5 cannot go towards 2 and simply return. Okay, simply return. Okay, now 5 will try for 6, and here try for 6, and 6 is unattempted or unvisited, so 5 can go towards 6. Okay, this is right path. Now if you go towards 6, then 6 will be ticked and value of 6 will be 1. Now 6 will try for all neighbors. Thus the neighbor of 6 is 5, so 6 will try for 5, but 6 cannot go towards 5 because 5 is already visited, value of 5 is 1, so you simply return. Okay, now 6 will try for another neighbor, so another neighbor of 6 is 2, try for 2. Okay, but 2 is already visited, 1 value of 2 is 1, so 6 cannot go towards 2 and simply 6 return. Okay, now 6 have attempted all neighbor 5, 6 attempt for 5, 6 have attempted for 2, so 6 will simply return this call. Okay, 6 simply return this call. If 6 will return this call, okay, so he reached toward 5. Okay, simply return this call and return at 5. If returned at 5, then 5 have tried for 6. Okay, now check and look at 5. If you are at 5, which is returned from 6, if you are at 5, 5 will 5 have already try for 6, then 5 will try for another neighbor which is 2, so 5 will try for 2, but 2 is already visited, so 5 cannot go towards 2. Okay, so 5 already try for 6 and 5 have already tried for 2, That means 5 have attempted all its neighbors, so 5 will simply return its call towards 5. Sorry, 5 will return call towards 2. Okay, and if you are at 2, okay, return call is at 2, then 2 have tried for 5, 2 have tried for 1 because 1 is visited, the 2 have 2 have 2 other nodes which is that 2 had not attempted. So 2 will try for 6. 2 will try for 6. But 6 is already visited. Okay, because here 6 is already visited. So 2 cannot go towards 6 and simply return. Okay. Now 2 have attempt for 1, 5 and 6, but another unattempted, that means 4 is unattempted for 2. So 2 will try for 4. Okay, that means 2 will follow this path. That means 2 try for 4 and go towards 4, and 4 will be ticked and value of 4 will be 1. Okay, now 4 will try for all neighbors. So neighbor of 4 are 3 and 2. The first 4 will try for 2, but 2 is already visited, so 4 cannot go towards 2. Then 4 will try for 3, and 3 is unvisited. Here 3 value is not 1, so 3 is unvisited, so we can go towards 2, and 3 will be ticked and value of 3 will be 1. Okay, then 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 3 will try for all neighbors. 3 will try for 4. Okay, but 4 is already visited, so he cannot go towards 3, cannot go towards 4, simply return. Okay, and then 3 will try for 1, but 1 is already visited, so he can 3 cannot go towards 1 and simply return. Okay, now 3 have attempted all neighbor 1 and 4, so 3 function call will return, simply return towards 4. Okay, parent call, parent function, that means 3 call function will be simply returned to the parent function, that means 4. If call is returned at 4, then 4 have already attempted all its neighbor 2 and 3, so finally 4 function call will similarly return towards parent, that means towards 4, and currently the call will be at these 2, and 2 have attempted all this neighbor. 2 have already attempted for 1, attempted for 4, attempted for 5, and already attempted for 6. So now all the neighbors have all the neighbors are attempted of 2 nodes. So 2 will simply return its call to the parent, that means 1. So 2 will simply return call to the parent 1. And now parent have 1 have 2 neighbors. Okay, 2 and 3. 1 parent 1 have 2 neighbor 2 and 3, and 1 have attempted 2. Remaining left is 3. So 1 will try for 2 for this path. But check 3. This 3 is already visited, so 1 cannot go towards 3. Okay, so 1 cannot go towards 3, and then all the neighbor of 1 is already visited, that means 2 is already visited, the all 2 is already attempted, and 3 is also already attempted, so 1 cannot attempt 1, that means 1 cannot attempt any other neighbor, it had attempt all its neighbors, so final call will be returned. Finally the main function will return from here, and you can say that all the nodes are ticked, that means you have visited, and also visit of all the elements is all the nodes value is 1. Okay, so that means 1 all the nodes are visited. This is actually the depth first search, DFS, depth first search traversal. This is the algorithm. I can try this approach by making adjacency list. Okay, so you can understand clearly what is the adjacency list of for this. Let's spreadly 1 2 3 4 5. I try through adjacency list because finally if you write DFS then adjacency list will be used, so you can analyze clearly that how adjacency list is used for this DFS or how adjacency list work. Okay, what is the name? This is unordered list, so 1 2 4 1. This is for this is 1 for this is 1. You are 2 in 1 and 1 in 2. This is 2 5, which into 5 2 and 5 into 5. This is also 5 6 in 5 in 6 5 and 5 in 6. This is 2 6 into you will add 6 and in 6 you will add 2. This is 2 4 in 2 you will add 4 in 4 you will add 2. This is 3 4, that means in 3 you will add 4 in 4 you will add 3. This is 1 3, in 1 you will add 3 and in 3 you will add 1. This is actually the adjacency list of this graph. Let's follow the same path. Okay, if you try to follow same path, I want that you can clearly see how this algorithm is implemented by adjacency list. Okay, let's first, if you start from this is visited. Okay, if you start from 1 and you tick 1, or also try to make all no one. Okay, if you start from here, that means the value, if you must start from 1, then you will pick 1 and visited of 1 will be 1, visited of 1 will be 1, and if you are at 1, okay, then you from 1, actually from 1 you can go towards 2 and 3. Okay, let's you go from 1, that means 1 is ticked, you go towards 2 and 3. Now here 2 is all non-visited, so you can go towards 2, so make value of 2 is 1. Okay, if you are at 2, that means you are at 2. Okay, if you are at 2 from 2, that means here 2, you can go towards 1 5 6 4. That means if you are at 2, you can go towards 1 4 6 6 and 5. And this is same thing you can see from here. If you are at 2, you can go towards 1 5 6 and 4. If you are at 2, that means 2 is already ticked, same, so you can go towards 1, but 1 is already visited. Okay, already visited, so you cannot go towards 1. Then from 2 you to go towards 5 and 5 unvisited, so you go towards 5 and make 5 visited. Okay, 5 ticked. Then now we cannot go towards 6 and currently you are at 5. Okay, if you are 2, then 2 to 5 and 5 to here 5, and if you are 5 you can go towards 2 and 6. If you are at 5 you can go towards 2 and 6, similarly 5 2 and 6. Then you try for 2, but 2 is already visited. Here 5 you try for 2, but 2 is already visited, so you can go not towards 2, you will try for 6. and here 6 is unvisited, so one value of 6 will be 1 and 6 will be ticked. Okay, that means you have visited 6. If you are at 6, then you try for 5 and 2, and 5 will be already visited. Okay, 5 have already visited, so 6 will try for 2 and 2 have also already visited, so 6 cannot go 5, go for 5 and 2, simply return. The 6 call will be simply return, that means 6 call, and 6 is called through 5, or 6 is called from 5, that means 6 call simply return towards 5. That means currently call will be at 5. Okay, this 6 call currently return towards 5, same. Okay, that means you are at 5. If you are at 5, you have attempted for 2, you have attempted for 6, that means all the call neighbor call of 5 is done, so 5 simply return its call for parent. What is the parent of 5? Here parent of 5 is 2, because 5 call is called from 2, so all the nodes of 5 is done, so 5 simply return the call towards 2. Now 2 have already done 1, because 1 is visited, already done 5. Now 2 call for 6. Okay, now 2 will call for 6 and 6 is visited, so cannot call. Now 2 will call for 4. Now 2 will call for 4. So here 4 is unvisited, so 1 4 will be visited, 4 will be ticked, 4 will be ticked. If 4 will be ticked, then come at 4. Okay, come at 4. And what is the neighbor of 4? 2 and 3. 4 try for 2, but 2 is already visited. Now 4 will try for 3, come at 3, and 3 is unvisited, so he called 3 and 3 will be visited and 3 will be ticked. Now if 3 will be ticked, then also 3 will be ticked, and call function call will be at 3, and 3 will try for 4, then 4 already visited. 3 will try for 1, 1 is already visited, so simply 3 call will be return towards 4, because 4 has called 3, so 3 called has 3 called will be returned towards 4, and 4, now 4 have attempted 2, 4 have already attempted 3, now 4 call return 4, the 4 function call will be returned. What is the parent of 4? Parent of 4, here 4 is called from 4 is called from 2, so 4 simply call will be returned towards 2, and 2 have attempted all its neighbor, so simply 2 will return its call to the parent, that means 1, because 1 have called this 2 function, so 2 function have already done this neighbor, so 2 function will be returned towards 1. And now 1, if you are currently at 1, then 1 will 1 have attempted for 2, then 1 will try for another neighbor 3, and 1 will try for 3, and you see that 3 is already visited, so 1 cannot go towards 3, and final call of 1, that means 1 have done on its neighbor call, and finally call will be returned, and that means DFS traversal has done. So actually this is DFS. Okay, this is DFS traversal. I think there will be much clarity about DFS and how you can write algorithm. So if you can also try shortly for DFS with one practice, so understanding, good at understanding will be okay. Let's one practice of GFG. Let's here graph, adjacency graph. For simplicity, I try this adjacency, that means this is graph. Okay, this is graph. You can take any name. Okay, you can keep any name, but I mainly prefer name adjacency list as graph. Okay, so that means that graph is already given, so you have only try DFS. That means if you are, that means one in words, you first make visited array, So try int visited of new int what size, number of nodes. Here v is the number of nodes, so number of nodes is capital V. Make and all the value, that means default value is 0. Okay, in Java, so don't need to fill 0. Now try for all nodes. Okay, try for all nodes, that means for int I equals to 0, I is less than v, that means you try from 0 to v minus 1, I plus plus. If here you call any function, if the, that means if you are at 1, you will call to 1 and only if 2 will be unvisited. Okay, so that you will call if visited of this I equals to 0, then if visited of I equals to 0, you will call for DFS. We will make one function DFS. In DFS we will pass graph, also we will pass I, that means node, from node you call. Okay, and this is and you call and one make pass visited array. Okay, and this is array list. Okay, this is array list, so we try to make one list of integer that will store the visited array. List equals to new array list, and you have to pass this list also. Okay, so this list. Now you have done, that means we will try for each node. We have try for each node. What DFS, here is graph, so this is graph. We have to copy, control. One is I do not that node. Okay, node. Another is visited array, another is list of integer, list of integer. Okay, if okay, I have done approximately. Okay, here if you go towards any call, then you first tick and make visited as 1. Okay, this tick includes that you have visited 1. This tick, that means you will add this 2 in array list. Okay, that means you have a store, and visited, that means you tick visited equals to 1. That means you have to make visited of node equals to 1 first, and then try to add list dot try to add this node in list. Okay, and finally if you have picked any node, then you try. Okay, you tried for all its neighbor that is unvisited. If you have any node, then you first visited tick, and you tried for all its unvisited neighbor. Okay, then for now this call is for neighbor. Okay, graph dot get graph dot get node will give what? First, graph node dot get node. If you are at any node, then node size will give. If you are at 1, then if graph dot get 1 give this array list, and this array list, it will have 2 elements. That means this array list dot size will give all the array list element. Okay, so you can call for all array list element. Okay, graph dot get nodes. Let first, what is value? Int child equals to graph dot get of node dot get of I. Graph dot get node dot get I. This get I, that means a child includes all the neighbor of node. Okay, and if visited of that child, we will call only that child that is unvisited. Okay, then if this child unvisited, then they will call, then you call, okay, graph and pass this child, and then visited and then list. I think I have done. Okay, and this call will return answer, that means return finally list. I think this call session expired. Think this will run. Okay, okay, here integer list integer. Okay, cannot be control. This is, here we have written array list, and this is list. Let's see. Okay, so this will be the answer. And array list graph we have to change. Okay, I think this will be bed of print type array list is equals to graph dot get not plus plus. Okay, sorry, this is dot size. Okay, because this call will run for all neighbor. Okay, this call should be run for all neighbor, so we made for loop for all neighbors. So now this compiled for first test case. Let's change for all test case. Okay, finally all the test case have passed. So actually this is the code for DFS traversal, or this is the algorithm. Okay, thank you. In next video we will discuss about BFS.